I'd like to start with you with Peirce inference processes. Charles Peirce, the semiotician. He emphasized there are 3 inference processes, not 2. Most of us think in terms of science as based on deduction, deductive analysis. But actually, you don't have only deduction as an inference process. And I would say most of the time when you use deduction, like experimental designs, it came from a first exploration that was inductive. For example, you have to explore which settings would be good for you doing an experimentation, what type of experimentation would you do, what type of research, and then the first phase is inductive. So induction is very, very useful. When I was training teachers, long time ago in Geneva, I used to teach them what's induction and deduction in bringing, like I had 2 groups of teachers, 10 and 10. So I brought 20 watches, you know, electronic watches. And for one group of 10, I would give the guidelines so they could read the guidelines, how to fix the time for the watch. So I would put the time random. And then the second group of teachers, they had no guidelines, okay? So guess what? The teachers who had the guidelines, it would take for them about 10 minutes to fix the time because they just read the procedure, okay? It's a deductive approach. You know the rules, you apply the rules. And those teachers who had no guidelines, they would take 15 minutes to fix the time. Why? Because they were going through a phase of exploration, which took about 5 minutes, and after they could fix the time. 1 week after, I would come back to the class and I would give them the watches. And I would give no guidelines at all to anybody. So all of them had to work inductively. And you know what happened? Those teachers who had no guidelines the first time, for them it took 10 minutes to fix the time. Those teachers who had the guidelines the first time, they had to relearn everything. It took them 15 minutes. So you see the debate over whether we better teach things inductively or deductively is there. If you teach the rules and then they have to apply, as soon as they don't have the rules in front of them, they forget them. They have to recreate them inductively. So you learn inductively and then it lasts forever. Your knowledge is for life. That's the reason why there are so many people who maintain that there should be an inductive dimension to learning. You have some types of research that are deductive and presented as more scientific, more rigorous, because you start with a rule and then you apply the rule. There are many people who think it's more scientific. Actually, there is no meaning to the word science that is restricted to a way of using inference. And Peirce said there are 3 ways of inferencing. The first is inductive. That means you have one case and you infer from the case a possible law. The second process of inference is deductive. You are given the law, is the generalization. And from that law, from that generalization, you analyze one case to see if it matches the generalization or the law. I would say that both are scientific valid ways of inquiring. There are ways that are deductive, there are ways that are inductive, and both are fine. And both enter into different epistemologies. That means epistemology, ways of knowing, different ways of knowing about science. different definition of science. One is top-down, that's deductive. One is bottom-up, it's inductive. You have mixed ways of doing research in which you do also not only bottom-up, but also top-down coding. You have a theory, you test the categories of your theory, but you let emergent theories come in your analysis of the data. So you can do both. Now, Charles Peirce, the semiotician, was proposing a third inference process, which was abduction, AB, abduction. Actually, it's a complicated word to say intuition. It's not that the law comes first and then the application. It's not that the case comes first and then you infer a law from one single case or a few cases. It's more that suddenly you have a kind of a clear perception of the law. Intuition, it goes through your intuition. You have a kind of a global apprehension of the law. Now, I'm going to tell you that this abductive approach is not used in current science much. There are very few people who use abduction as a way of doing scientific research. Very, very few. I think it would be methods for the future. You might say it's counterintuitive, no? Using intuition for science. But actually, there has been a lot of research on how scientific discoveries emerge in the mind of a scientist. The big top theories, you know, Einstein's theory of relativity, where did it come from? You might be surprised, it came from his dreams. He was dreaming, and then it came out. Pasteur, the guy who found antibiotics, you know, who find X-rays, who find ways, where did he find that? Through deduction, through induction? It came during his dreams, during the night. He had dreams that manifested into his discoveries. Other people, they were walking along a lake and they found suddenly, oh, think about Newton. Newton in physics. He is resting under an apple tree and suddenly an apple falls on his head. Boom! Abduction. Intuition. Okay. And you cannot know, you cannot say these are minor discoveries. You know, Newton, 5 centuries of physics research were done on Newton theory. I'm telling you that to open your brain, to open your mind. Why? Because nowadays, science has been schooled. It has been transformed into a fixed curriculum. And that's the problem with curriculum studies. When you create valid knowledge, it becomes exclusive knowledge. Knowledge considered valid is kind of considered final, and it enters into an unfair competition where it's superior to any form of knowledge.